Okay, this is the Chapter 3 quiz. The first problem wants us to put this function in vertex form and determine the values of a, h, and k. There's different ways to do this. We talked about completing the square, which I think I showed in the homework video. But I'm going to do this one by using the x-coordinate for the vertex, x equals negative b over 2a. That's on the formula sheet. That will give us h. So negative b would be negative 64 over 2a. So that's negative 64 over 16. That gives us negative 4. So then we can plug negative 4 in here and get the corresponding y value, which is k, right? This is h and k. The x-coordinate for the vertex is always h. And then plug it in and get the y-coordinate for the vertex k. And if you plug that in, you get 8 times 16 plus 64 times negative 4 plus 17, which gives you negative 111. So assuming that I did this right, and that's my h and this right, and that's my h and k, then I can go ahead and write vertex form out. My a value I have right here, because right, this is ax squared plus bx plus c in standard form, so my a value is 8. And then h is negative 4, so double negatives cancel, turns into plus 4, and then minus 111. So there's my answer there. My a is 8, my h is negative 4, my k is negative 111. All right, consider this quadratic right here. The vertex is at negative b over 2a. So that'd be opposite of opposite 9, which is 9, over 2 times 2 equals 9/4. And you can plug that back in here and get the corresponding y value, which if you plug in 9/4 in here, you get negative 361 over 8. I did it as a fraction of my calculator, so you could do it as a decimal as well. That'd be fine. And then the next thing is I want the x-intercepts. The x-intercepts occur at on a graph where y is 0. So this is a parabola, so hopefully it has 2. Or it could have 1, or it could have 0. But you set it equal to 0 and solve for x. Now I'm going to do the quadratic formula with that. So it's opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to simplify this. Double negatives go positive. And this whole thing simplifies to 361. And then the square root of 361 is actually 19. So you get 9 plus 19 over 4. So you get 14 and 10 over 4, which simplifies to 5 over 2 if you do both of these. So there's our two x-intercepts. We can list those with a comma. And then the y-intercepts occur where x is 0. If you look at a graph, the y-intercepts are where x is 0. So plug in 0 for x, and you get negative 35 for y. And so I think it just wants the negative 35, not the order of pair. Okay, the next problem gives us an equation for the height, y, in terms of the horizontal distance. So x is the horizontal distance. Well, sometimes it helps to write the variable down so you know what it is. And this is the vertical height. And then it says how high is the ball when it leaves the child's hand. Well, we know what this thing looks like. It's a parabola. How high is the ball when it leaves the child's hand is right here. We can get that from the graph, or we can just plug in 0 for x. If we plug in 0 for x, we get 3. So that's just 3 feet. And then what is the maximum height of the ball? That's the vertex here. We can get the vertex by hand by doing x equals negative b over 2a. For the x-coordinate, plug that back in to get the y-coordinate. Or we can look at the graph. And on the graph, obviously, we would have to scroll out. And we would have to get the vertex here. So 16, comma 9 is the vertex. So this is the point 16, 9, and then it's what's the maximum height? That's the y-coordinate. That's the vertical height. So we would say 9 feet. And then how far does it strike the ground? Well, that would be the x-intercept. I can get that by setting y equal to 0 and solving this equation using the quadratic formula. Or I can get that from Desmos with the graph, so that's what I'll do. It's a little quicker. So I'll get it right here. Just 33.44 feet. Okay, the next problem, a polynomial of degree 5 has leading coefficient 1 and roots multiplicity 2 at 5 and at 0. So that'd be x squared and x minus 5 squared. Multiplicity 2 means we have an exponent of 2. And it's x minus 0 for the factor. It's x minus 5 for the factor if these are the two zeros. And then it's got a root of multiplicity 1 at x equals negative 3, so that'd be x plus 3 to the first. Now there's our equation. We're done because a leading coefficient of 1 means that our a value is going to be 1, which it will be if you multiply all this out. So we'll just leave it just like this, and what they want you to enter in is this part. The next problem says take the degree number of terms in the long run behavior of this polynomial. So the degree of this thing is going to be degree 3. There's 3 x's. When we multiply it out, we know we're going to get degree 3. And if you FOIL this whole thing out, you're going to have like, something, we'll say 3x squared plus 2x plus 7. So you're going to end up with 4 terms. Now, I didn't FOIL this whole thing out, but if you did, you get something like this. So it's a degree 3, the number of terms is 4. And then we can look at the end behavior. Now, if we look at just the x's, you multiply this x times this x, and you're going to get 4x squared. Then you multiply the 4x squared times this negative x, and you get negative 4x cubed. What that means is this is a cubic polynomial that's been reflected over the x-axis, so it's going to look something like this. So that tells us, and you can graph it in decimals if you want, just like this, and you'll see something like this, where what does the y value do as x goes to positive infinity? That goes to negative infinity. I think you have to type the whole thing out. And then as y goes, what does y do as x goes to negative infinity? That goes to positive infinity. You have to type that out as well. Okay, the next problem gives us the 4th degree polynomial, and it wants the minimum value, x and y. It's kind of weird. Usually you do x, y, but this says it flipped. It says keep at least 3 decimal places. So graph this in decimals. The minimum value, you're going to have to zoom in to get these 3 decimal places. And obviously you can do this in your calculator as well. But let's say 4.25 and negative 18.543, and give the y first and then the x. The next equation wants a cubic function with these zeros, so that'd be x plus 2. We'd have x minus 0, which I'll write as just x, and we'll have x minus 6. And we also want it to go through the point 88. That's what this means right there. Function notation says that's our x value, that's our corresponding y value. So there's some a value in front of this, and I'll use y instead of f of x for now. I'm going to plug this in for x, so I have a times 8 plus 2, which is 10, times 8 minus 6, which is 2, and that equals our y coordinate, which is 8. Now I can simplify this, so I think the 8's cancel here. We get a times 20, so that means my a is 1 over 20, like the Bible says, by 20, and that just goes in right here. So that's my answer that I'm looking for. There's my cubic that satisfies the conditions that they gave me. Next problem wants us to do long division and then look at the remainder. So long division, we're dividing this polynomial in, so we're dividing the polynomial x minus 2, which comes from that factor right there, into this polynomial x cubed minus 9x squared plus 18x minus 12. Now I know we can do synthetic, and synthetic is probably easier, but it wants us to do long division, so let's show our work. Multiply by x, we need x squared times x to get x cubed. Follow through and you get negative 2x squared. When you subtract, it gives you negative 9 minus negative 2, which is negative 7x squared. And drop down the 18x. So then you're going to multiply by x to get, we want to get negative 7, so let's negative 7x. And when you multiply, it gives you negative 7x squared. Follow through, it gives you positive 14x. Now when you subtract, you get 18 minus 14, which is 4x. Drop down the negative 12, and then start over again. So what do we need to multiply by x to get 4x? That'd be 4. 4 times x is 4x, and 4 times negative 2 is negative 8. So that gives us a remainder when we subtract of negative 4. And so that's our remainder. What we do usually is put that plus negative 4 over the divisor x minus 2. So, but we can just write the remainder right here. Quotient is x squared minus 7x plus 4. And then P of C, when we stick this in, the remainder is what P of C is. That's the remainder theorem. It says that if this is a root of the equation, or if we plug this into the equation, the remainder is our y value that we get back out. So they're both negative 4. The next problem says 2 zeros are 1 and 7. The other 2 zeros are real but irrational. Well, 2 zeros are 1 and 7. We can divide those in. We can actually, if we want, there's 2 different ways to do this. We could multiply this out and do long division again. We'd have some, x squared minus 8x plus 7. And we divide that into this polynomial, and we get a quadratic left over. You can do that if you want, or you can do synthetic twice. If you do synthetic twice, you'll get that same quadratic. So I'll do synthetic twice, divide 1 into this 1, negative 4, negative 24, 20, and 7. drop down the 1, multiply, add, multiply, add, multiply, add, multiply, and you get no remainder, which we don't want remainders for this one because we were told they went in evenly. If they're roots, they do anyway. So then divide 7 into what's left over, drop down the 1, and multiply. 7 gives you 4, multiply, you get positive 28, add, and you get 1, multiply, you get 7, no remainder. So it turns out my quadratic that was left over was x squared plus 4x plus 1. And they want to know the other two zeros that come from this quadratic. So set that equal to 0 and use the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. 16 minus 4 is 12. The square root of 12 is really 4 times 3. And the square root of 4 is 2, so it's negative 4 plus or minus 2 square root of 3 all over 2. Now we can simplify this. 2 goes into 2 once and 4 twice into this one, so it's negative 2 plus or minus the square root of 3 all over 1. So it's negative 2 plus or minus the square root of 3 is your two answers for your irrational answers. Okay, more practice with synthetic division. We're going to divide negative 7 into this. 1, 7, 7, 53, and 32. So we're going to drop down the 1, multiply, add, multiply, add, multiply, add, and then multiply, and the remainder we get is 4. And so the quotient is x cubed plus 7x plus 4. And then I don't have to write this 0x squared. The remainder is 4, and that means that that's what I get is what's left over. If I plug in that value, it's the y value is also the remainder. That's the remainder theorem. It's easy to say. Okay, we're going to use synthetic division again to divide 7 in to this polynomial. We have 1, negative 13, 26, 112. We're going to drop down the 1, multiply. You're going to add and get 6. Multiply. 42. I'm sorry. This is negative 6. This would be negative 42. Add negative 16. Multiply. You get negative 112, which when you add these you get 0, which is good. So that tells me my quadratic is x squared plus negative 6x plus negative 16. Now, they told me this factor completely, so far we know that one of the factors is x minus 7. We divided that in and we got this quadratic, x squared minus 6x minus 16. Well, if it factors completely, this should factor as well, so we should be able to factor this quadratic into two linear factors. So let's try that. Two numbers that multiply to be 16 and add to be negative 6 would be negative 8 and positive 2. And so there's the factorization completely. Now they want plus, so I'm going to write this as x minus a negative 7, just to show you, and then I'm going to write this as x plus a negative 7. I'll write this as x plus a negative 8, and I'll write this as x plus 2. That way you can see that if you change these to pluses, that means my a is negative 7, and then my b is negative 8, and my c is 2. I don't know what order they want these in. I don't know if you need to put the smallest value first or if it doesn't matter. But there's a list of values for my a, b, and c the way that they wanted them.